Thank you very much to NCS and also Sam under his leadership. This is the first event, Impact, that I'm joining and presenting here. Thank you to NCS and thank you for all of y'all to join here. I've given 15 minutes. I'm going to make sure I'm going to deliver a key message. Agentic AI is real. It's here in production, in enterprises. 4 key takeaway messages. Why Agentic AI now? Next, why trusted agents are very, very critical. Next, it's not only any more single agents, it's multiple agents are working together to solve a problem. And finally, why do you need AI factories to run all the agents? That is a 4 key message I want to share with you today. And as you all have seen, and you are working with agents, you are working with many of the applications today, agents can plan, can reason, can critique, can work together with multiple agents, solve a specific problem with human in the loop or even without human in the loop. I want to walk through how we can achieve this. And finally, I'm going to close it with a note on token economics, which is very, very essential. So we have seen the moment of ChatGPT. We have seen DeepSeek in terms of reasoning capability and OpenClaw. And the performance are just staggering. It's just excited. I'm excited to see, all of us are excited to see how the agentic AI evolving so fast. Now, if you can see, as a human being, you may do 20 search through a search engine, 30 search, 40 search a day, right? As you're doing work, you go and type your search queries. But agents per minute, it can generate more than 20 queries for you if you're actively prompting per minute. And agents can run 24/7, not like us. We take a lunch break, we take a coffee break. So imagine number of tokens that the agents creates, not single agent, multiple agents. It goes into billions of tokens. That's why token economics are very, very important. I'll cover to the last. You can see today agents are working together. It does tool calling. It works with different file system. For example, using a rack pipelines. It has VLLM. It has LLM. It has a VLA for robotics. It has a ALM, audio language model. Multiple models are emerging, and the agents are able to work with all these tools, call them together to solve a problem. And we are seeing more sub-agents are being created. Sub-agents are vertical specific. For example, you take a healthcare. Agents which are being created, of course, you can use frontier models to solve all the problems, but you may not need frontier model to solve every problems. Some of the models works very well for vertical specific. For example, within healthcare, a sub-agent can be created with a sub-model to solve a problem on a genomic sequencing. Or if you are looking at MRI image reading, you can have another agent which is trained with a specific model to do MRI reading. So what we are observing is there are multiple agents. Each agent may use some of the model, or each of the agents may use many of the models, and these models are changing and new models are being created. If you can see in the over past few years, the curve shows you in terms of GitHub distribution to 20 million. From the year 2023 to 2025, it's all done by human being. But 2025 onwards, human being has been assisted by AI agents, and we can see it in terms of the GitHub contribution. So what does it show? Agent-assisted tasks can bring you better productivity. It can give you better efficiency. That is proven. And what we are looking at is there are more and more open source models are coming out. Open source AI agents are being created, and specialized AIs are required. As I shared with you, we have many frontier models doing complex tasks. It's fantastic. We have many of these open models being created by East and West, and we get best of the both to use as a developer. Now, using these models, what people are doing is they are creating a much more specialized AI. There are companies that I'm working with globally. They have 70, 80, 100 over models being created, and each and every model being used in a specific workflow. And each of these workflow are solving a problem in the steps that you're trying to solve for a specific scenario, specific use cases. In order to make sure these agents are being effective, the models being called are effective, you need to make sure that these agents and the models are efficiently being fine-tuned, being used for a specific purpose for the outcome that you want with the token efficiency. Now, what we are seeing is the specialized agents are very important. They can be domain specific, solving a specific problem. They can be adaptive. They can keep learning because the LLM changes, the VLM changes, the VLA changes. They can be adaptive. They can continuously learn. They can manage your data. They can manage your IP. Of course, you must make sure. The second topic I wanted to share with you is trusted agent is very critical, and it can actually optimize costs when you have optimized agent, optimized model, whether you're using NVFP4 in terms of model optimization, whether you're doing token optimization, or you are actually doing model optimization by pruning, distillation, and so forth, is very, very important. Finally, for enterprises, it brings employee efficiency and increased productivity. So one of the important tasks that we see from the developer perspective is RL. Even though its model has been trained, model is ready for production, you must continuously improve your model or your agents through RL. So you can use, there are many RL tools available. From NVIDIA perspective, we call NeMo RL, reinforcement learning. We observe it can increase accuracy of a specific agent or model up to 16% when you fine-tune the model or fine-tune the agent to do a specific task. There are, for example, a GRPO or DPO algorithms being adopted, and we put that together in terms of one, what we call as a framework or library or toolkit, which is NeMo Agent Toolkit. We put together, I'll share with you the entire stack. We experimented, a lot of our developers are experimenting it, using it. It brings a lot of productivity gain in terms of token efficiency. Next, useful agent is here. It must be also trusted agent. By default, you cannot trust an agent. Zero trust until you provide the environment where the agent can work in a trusted environment. Because agents can handle sensitive data. Agents can interactive and work, because some of the agents may run for 1 hour, 2 hours, 1 day, or even 7 days. Environment changes, information being exchanged through API call changes in a day. So you need to make sure that if it gets an unintended prompt being injected by the tool calling from third-party API or from external environment, the agent must know how to behave and how to act on this injection which is coming in. Next, the agent can evolve from what it's learning, because LLM could be changing. Data sources where it goes and read could be changing. How do you manage the behavior is very critical. Governance and also security gap exists. So you need to make sure a trusted agent's being created. That's where OpenShell, what NVIDIA has built, it makes sure that each and every entities are in a separate sandbox. For example, agents in one sandbox, and the orchestrating component is another one more sandbox. And finally, all the tools that you put together could be another sandbox. And all of them must be governed by policy and also signing capability, or basically guardrails. So NCS, for example, working closely together with NVIDIA using our OpenShell, and they have released Guardian as one of the product. Now, we feel this is very important to make sure that you have a secure and trusted agent is running. This has to be a first principle as you build and deploy agents either for yourself or for your partners. So these are some of the guidelines. For example, make sure you enforce out of the process model. The agent should not do things that he's supposed not to do. Trust is a zero trust. That means you don't trust the agent, and you must control activity of agents. You must know the origin of access, where data goes, data comes, where the API goes and comes, right? And then kernel level protection is very, very important. So kernel level protection in terms of how the data being accessed, what kind of process being invoked, what kind of task being executed must be at a kernel level. And finally, NVIDIA provides GPU hardware level acceleration, including, for example, encrypted dataset execution at hardware speed. We call confidential computing capabilities. So we provide entire full stack capability for you to have full secure agent deployment. So another toolkit that we made available for you to go and try is called NVIDIA Agent Toolkit. Having a prompt coming in, there is an agent harness. You can use any agent harness. There are skills that you can use. You can have many models that you can actually bring in. All that you put together, you can execute using NeMo agent toolkits. The next, it is not anymore one agent. It's a multiple agents working together to solve a problem. So there are planner agent, there is a domain expert agent, there is a verifier agent, and for example, context orchestrator agent. So all these tools are going to work together working with a multiple agent, doing multiple problems. So managing the agent, understanding the behavior agents is going to be much more complex. So that's why you need to have a trusted and manageable environment. One example of a blueprint that NVIDIA provides is called Agent IQ. I suggest go and take it, experiment it. It's a fully open source. The entire source code is given, and all the software component is there as well. It's open source for you to go and experiment it. And we put that together into a multi-layer agent toolkit, which has many capabilities, including, for example, observability. How does the agent behaves? What kind of a memory segment is he reading? What kind of agent is being called? How long the agent is running? How many agents that the agent is calling in terms of accessing memory, GPU memory, or CPU memory, and so forth, right? The full stacks allows you to go and experiment. Again, NAT, or an agent, NVIDIA NeMo Agent Toolkit, it's an open source. You can use any of the component. You can bring it into production. You can deploy it. And we work with many agentic framework partners as well, as listed over here. You can bring any one of them. You can put together with NAT. You can develop your own solution as well. Now, we also built a model, 500 billion parameter model, which is called Nemotron Ultra. It is very good for reasoning. You can take it, you can put together, you can experiment as you build your AI agents using Nemotron 3. It gives 50% efficiency of your agent as it executes to perform a task. Remember, token economics is very, very critical. How efficient is your token? It is very important because at the end of the day, you're going to pay for your tokens, whether you generate on your own, non-meterized compute, GPU compute they may have, or you have a meterized compute sitting in your partner network or CSP and so forth. Having efficient agent and efficient model is very, very critical. NVIDIA also provides a list of libraries which you can use it in terms of skills for you to develop your own applications. Let's do it. So you have seen in that particular demo, we have used Omniverse, we have used Perplexity, we used co-opt, and many of the libraries in order to get a task done. So there are multiple agents running in concurrent. It runs on OpenShell in a control environment where we give a security access for the skills that we have actually implemented for you to go and experiment. The skills are open source. You can take it and experiment for yourself. Now, putting all this together, you need a full stack solution. In terms of the top layer that you have is Agentic AI solutions with a physical AI, and also you can even have HPC solution running on the same infrastructure. We have AI operational or MLOps AI ops platform provided by NVIDIA. It runs on secure environment using NVIDIA's compute and platform. So the full stack is very, very important for your AI factories. And NVIDIA has more than 400 accelerated libraries cutting across different areas. in terms of image processing, sensor processing, healthcare, robotics, and so forth. We have made all this software available to you for you to go and access. And many of this software comes with the vertical specific skills, vertical specific agentic AI, the NeMo agent toolkit able to be applied across multiple verticals. You have a lot of open source models from NVIDIA, Nemotron as an Nemotron example. We have Nano, Ultra, and Super. We have Nemotron Omni, and so forth. You can go and experiment all these particular models across different domains, and you can experiment how the token economics works for you. Finally, NVIDIA is the leading open model ecosystem provider. We put together across all the industries, covering in terms of platform and SDK, for example, BioNemo, Earth2, Nemotron, Cosmos, Groot, robotics, autonomous vehicle. We put together, we provide many blueprints, many frameworks, open models, reference applications, libraries, skill sets, and so forth, so that you can experiment the full stack solution at your organization as an enterprise, or you can work with our ecosystem providers who provide solutions, and you can work with developers in any form. The GPUs actually made available for you either in a small form, which is Jetson. It can be in a workstation. It can be even a laptop, RTX Spark that we recently announced. It can be in the cloud. It can be in your on-prem solution. Across all, tokens being generated either for LLM, VLM, ALM, VLA, so that you can generate this token to solve a specific problem. By using a full stack NVIDIA solution, you can almost optimize 50% of token throughput that you're going to run, so that your AI factory is efficiently running to solve your multi-agent trusted agentic AI application. With that, thank you very much.